Okay. I'm Eric Jan. You may have seen me around here. This talk is going to be about machine learning, more specifically deep learning, more specifically neural networks and image recognition. So to give some background, I'm kind of an amateur photographer. I take maybe a few thousand pictures every year. So over the years, you can imagine, it kind of adds up. Recently, I discovered that Google Photos is trying to automatically classify my pictures. So I thought that's potentially very useful. It would save me from having to manually go and label every single picture. So I started digging around a bit. And, this is supposedly, these are birds. And in some cases, those are remarkable. I don't have a very powerful camera, not much zoom, so if there's any bird, it's usually tiny, so pretty impressive. There's definitely some misfires. Some are kind of excusable. Okay, there's some small, fluffy thing hiding in the shrubs. It's a chipmunk, but could be pictures of birds. Sure, why not? These mushrooms here, that's definitely, I don't see how that could remotely, possibly even ever be interpreted as a bird.
Looks like an owl.
Yeah. You squint and...
I like the rock bird.
Yeah, the one
top
on
corner.
top
I see three baby birds down with white heads.
So Google also has a web API where you can do requests and submit individual images, and I tried that to get a bit more information to see what's going on here. And it does, in fact, get the highest score for mushrooms, and even knows these are edible mushrooms. It doesn't correctly identify the species, but for some reason it still thinks it's some kind of animal. Then out of curiosity, AWS recently started offering a similar service. AWS is called Recognition or something like that, and surprisingly, they have a similar problem with identifying mushrooms as a bird. There's some hesitation whether it's a quail or a partridge. And then mushrooms further down on the list. So going back to Google Photos, this is supposedly dogs. There's in all of the entire collection, there's exactly one actual dog. See if you can spot it. And as a hint, it's not my wife. So that's Google. I figure, what do they know about machine learning? Surely I can do better. The other issue, of course, is even if they, so for this picture, they do a pretty good job at kind of putting labels on it. But it's not my vocabulary. If I'm labeling the picture, I would label it as a trail, not mountainous landform or whatever. So again, if you use one of the either AWS or Google's cloud service, you're going to be working with their predefined vocabulary, not your own. So I decided to have a closer look at my pictures. So first step was actually getting some statistics on what labels am I using, how frequent are they frequent enough to make it feasible to some kind of machine learning approach. This turned out to be much simpler than I thought it would be. There's an open source library, Apache TK, that basically lets you extract metadata from all kind of files, including images with just a few lines of code. So I ran that and used that to use the work cloud built from the data. And it turns out to have relatively, even though there's like total of maybe 40,000 images, there's only a handful of labels that are used like more than a few hundred times. And unfortunately, some of those, like view, they're probably too generic. That's going to be put everywhere where there's nothing else to see on the picture. And then there's things like tagging specific animals or plants. And that's probably a bit too difficult. There's another service that used to need that is pretty neat. It's called iNaturalist. The idea is you'll upload one or more pictures of some plant or animal or mushroom you saw, and they have their own trained neural network. They'll try to identify it, and from what I've seen so far, it rarely ever works. Sometimes they're kind of able to guess, like, okay, this must be a plant, but that's usually about it. It's still a very neat service to have, like, the whole community aspect. So you'll upload something, and then other people look at it, and they'll put on their own suggestions. So it's a useful service, but definitely that kind of gave me a hint that probably those guys couldn't figure it out. I shouldn't try to do like species level classification, especially since I have even less data. So that pretty much leaves me with the keyword trail. So I figured I'll just do write some code that will at least, so basically a quarter of my pictures end up being tagged with trail. So I figured if I can at least automate that tagging, that would be worthwhile. It's kind of inspired by, I don't know if anyone watched the most recent season of Silicon Valley, the famous not hot dog app. So basically, how do you do image classification? Pretty much everyone is using neural networks to do so, and neural networks, there's a zillion different types of neural networks depending on what kind of task you have. If you're looking at time series data, you'll use a recurrent network architecture. For image classification, everyone seems to be using something called convolutional network. So you can do some digging, and you'll come up. There's basically there's an annual competition called ImageNet, and you can kind of see whose models are scoring best there, and then these strategies basically copy those models, because you don't want to spend like a few years twiddling around and trying to build your own model. This is a very rough schematic of a network model called AlexNet. It was the state of art in 2012. There's more complicated ones meanwhile. And you can see it's pretty involved. There's lots of different layers, and there's tons of connections between the layers. At every point, there's different algorithms that can be, and parameters that can be plugged in. So you can spend a lot of time trying to fine tune this. So I went looking for a Java library to neural networks, and the first attempt is always to prefix a J. I didn't find any like J neural network or J learning or anything. So second try, you append for J, and success. There's a library called deep learning for J. So I started using that. So the network I showed in the previous schematic, if we were to build that using deep learning for J, that's basically how it will end up looking like. It seems like a lot of trouble, but fortunately they have some of the more popular networks. Basically, they have pre-configured, so just this one line of code. And then, of course, there's a few additional lines of code required to train your network. So one thing you need to do is you need to load your sample data. You need to have it randomly split into two parts. Maybe take 80% of the images for training, 20% for validation later on. You need to have some logic to extract the label from the images. In my case, go to custom class, it will go and get the label from the image metadata. That's the network initialization. This block here is the code for actually training the network. So there's a couple of things worth pointing out here. You need to kind of normalize your images, shrink them down, make sure they'll have the same dimensions, maybe do some normalization of the pixel values. Maybe you don't need like 24 64-bit color, grayscale is good enough. And once you're done training, you'll take your test data set and dump out some stats to see how well you did. And finally, persist your model you just trained because you want to use it later on without having to go through all of this. And at this step here, it can take anywhere, depending on how large your test data set and complexity of the model you're using, it will take anywhere from minutes to hours or even days. So you definitely don't want to leave out this part here. This is the output of a simple run just on a small subset of the data. You can see there's a whole bunch of iterations going on. You can see the scores changing. The final score here, not very impressive. The best I managed to do so far is 50% accuracy with 75% precision and 50% recall. What does that mean? So it means basically I'm detecting, according to this scheme here, it means I'm catching about half of all trail pictures, and the ones I do label as trails, they're actual trails in about 75% of all cases. So not terrible, but not terribly impressive either. This is another neat feature. While the thing is running, which I say can go on for ages. They have a UI. They basically have an embedded web server. You can start and you can see how things are going. Theory, this score here, you kind of trend towards 0. You can see that's not happening here, so you might consider aborting your run and twiddling with the parameters and retrying. So once you have a trained network, this is how you use it. So just a few lines of code. Basically, you load your model, you load the image you want to classify. You need to make sure you apply the same transformations, shrinking and downsampling on this image as you did to the images in the training set. And then this line here runs the actual classification and gives you a value from 0 to 1. I'll tell you how likely it is to get trailed. So here's some example images that were neither part of the training or the evaluation data set. So to me this looks like an obvious trail. What do you think? Trail, yes. Okay, success. Trail on a steep slope. Will we still be able to detect it? Yep. Again, is there a trail here? Yep, it's a bit hidden under the trees, and looks like that confuses our model. So we probably need more pictures with trails going through larches, and it'd be good. Here's another one, a trail with a tiny bit of snow on it. Is that going to be enough to confuse the model?
No.
No luck. Now there's just the faintest hint of a trail here. Surprisingly, it finds a trail here. Oh, it's got even more difficult. Is there a trail here? There is, but even when I was standing there taking the picture, I had a hard time seeing exactly where the trail is. So it detected as trail, but I suspect any picture of a rocky slope would probably have resulted in a trail classification. Okay, now for the most difficult example. Is this a trail or not?
Trail.
Yep. So clearly there's some more work to be done. Next up, I'll probably finish reading this book, so I'll have a clue what I'm doing. There's also this is the Coursera machine learning course. I'm kind of thinking about joining. It just started yesterday, so if anyone's interested, now is the time to jump on board. Another thing I'll do is so the current training I was running on my local machine, and I only have 20 gigabytes of RAM on my laptop, and that doesn't, like I said, the model I'm using, it was state of the art 5 years ago, so I couldn't run any of the newer models because they're too large and too much memory. So you can get, I'm going to get some larger instances on maybe an AWS. They now even have specialized instances with a GPU, a graphics processor. So deep learning for J can run natively on your processor, but it can also make use of a graphics processor that can speed up things a bit. So that's fine. So I guess you have to watch out, they're kind of pricey. So if you have a model that requires a few days to train, it can end up getting expensive. So I'm curious if any of you have used any other machine learning libraries. So I was talking about deep learning for J. The one that's currently seeing most activity and it's most popular is Google's TensorFlow library. This is written in Python and C. You could still, so even if you have a Java application, you could still use the, you could use Python basically to train your model, then you can dump your model, and I believe there's a Java library you can use just to run predictions on the model you built with TensorFlow, so it can still be an option. This other open source project called MXNet. It's C++ with bindings in, it has a Python binding. It doesn't have a Java binding, it has a Scala binding. That could be an interesting option too. Apparently Amazon is kind of throwing their weight behind this library. So there's lots of interesting options out there. Okay, any questions? Anyone want to share their traumatic experiences with machine learning?
So when you were training it, how did you label? Did you use Google to label your images, or did you label them?
So all my images, I have all been labeled them by hand.
Okay.
Yep.
The training is correct.
And that's my motivation. Like I don't want to spend all this time hand labeling them in future, maybe. But so far, it looks like AI hasn't put me out of a hobby yet. So.
How was the support for DL4J? Like, did you run into any problems, or what were some of the challenges, other than not recognizing?
It's definitely a problem. Like, okay, you can set up everything relatively easy, but then it's okay, it's just not working, and you need to dig into them and start fine-tuning parameters. And there, if you don't know what's going on with your hoods, you're stuck. There's a couple of things you can do, like, okay, let's throw more data at it, or let's clean up our input data a bit.
Is there a way to you can have multiple instances on AWS running together?
So they do have they use support for parallelizing this thing with Spark. You can have like a really large data set that you want to train in parallel. I haven't tried that. In terms of support, I was looking like on Stack Overflow, there's not much activity, especially compared to the Google library. They do have a pretty active chat forum somewhere, which is kind of chaotic, but there's definitely people hanging out there. So it's definitely active, it's not like an abandoned project.
And then the book you're reading, that covers the different deep learning algorithms and assuming use cases, or?
Yeah, it kind of has two parts to it. One is it tries to give you the kind of theory behind neural networks, and to be honest, it's kind of at the level that if you don't know anything about machine learning, it's totally over your head, and if you you're deep into it, it's probably boring. So it's probably better to but the second part it generally goes through some examples of using deep learning for J for doing specific problems. So that's where it's wrong.
Does the size of the training set have anything to do with the accuracy that you see? You know, if you have a training set with 100 images, 20 of them are trails, and 80 are not. that would give you one result. If you give 10,000 images,
Yeah, you definitely, generally speaking, having more images would increase your accuracy, but it can also, if you get more data, but it's kind of more varied data, then it could actually decrease your accuracy. So let's say if you start out with a very carefully curated small data set of some object and maybe slight variations in different animals, you might do very good at scoring similar type of images. But then if you add in like, oh, let's try to have all like, let's say my original set don't have like trails through forests, that might be I might do very well at recognizing trails through forests, but if someone puts like a snow-covered trail, I won't recognize it. So if you have a bigger data set, there's a bigger chance there's going to be sufficient snow-covered trails in there for you to be able to read. But if this, yeah, so it can increase your data, it can be good or it can be bad. And another factor is like how many iterations you do through your data set while training your model. So even if you don't know too much, there's a handful of things you can play with and try to get things working, so not all is lost.
no, I was thinking more of situations where if you have access to large amounts of data, you can almost by brute force end up with a very good filter because you get enough training data.
Yeah, I mean, and another thing they support, you can cheat a bit if you don't have that much data and you want more data. There's some kind of post-processing filters you can apply. For example, let's say you can flip your image horizontally, so you have twice as many trail pictures. You can do some skewing and some fiddling around with the colors, so that can help further increase your training set size and make your model more robust.
Is there a benchmark of accuracy, and how is that, if yes, how is that benchmark improving with time?
So you mean benchmark for comparing different types of different model architectures, or specifically for benchmark for one? The one scored a, so there's all these precision, precision recall. There is this thing called F-score, which is basically just kind of the so-called harmonic mean of the precision recall. That kind of gives you a number you can follow. Is it useful or not? That's kind of an open question. One problem you run into if you're trying to classify something that's relatively rare. Let's say only 1% of my pictures have actual chickens in them. Your model will soon learn that it can do pretty well by just basically saying there's never any chickens in your data, and it will be 99% accurate, right? So what you can do if you think like it's terrible to ever miss a chicken, that's like it's going to cost your company millions if that ever happens. You can plug in some custom scoring function that will be like a really bad case to missing a chicken. So that's one thing you can. Now, for comparing different model architectures, as I mentioned, this annual competition where there's a bunch of academics submitting their latest models, and whoever wins gets hired by Google or Amazon, whatever. So that's another way kind of to see like, okay, what's the state of art for specific problems. Okay, thank you.
Cool. All right, if I want to take a few minutes, do you want to get set up over here? So a couple of sandwiches left back there.
I usually go there a lot.
Oh, yes, I've never had one. I've had one, but it's not right there.
Yeah, on the weekend it's really like you're on the weekend. it's so packed.
Oh, is it? Where are they at?
If you go down to Jackson, and then there's a, I think it intersects with, I just know the area, you go to Jackson and then there's a little Vietnam. I forgot the crossroads, but
Oh, okay.
it's like right there, it's kind of hard. It goes into like right here.
Oh, is it biological
A lot farther
further?
east.
Oh, okay, gotcha.
Yeah. But if you go to South Jackson, you have to crosses over and
What's that?
That would go, that's big enough.
Okay. I don't think it's happening very often, but I'll have to try.
yeah, my kids always, my son always wants me to stop by. We usually go get haircuts
Oh,
over
really?
here.
Oh, nice.
And then we always like go stop by there, get a sandwich or so.
Oh, that's awesome. How old is your son?
He's 7.
And I'm surprised that he eats those. I have a son and he's 13 and he's so picky. He won't eat anything but pizza, mac and cheese, and hamburgers.
That's yeah. My son eats all of that plus.
Oh, wow. You're lucky. That's so great.
My daughter on the other hand, she's
Oh, really? So you have one of each too then? Picky and then picky.
she's the one I worry about. She grows so much, but then it's like, you know, what is she
Yeah.
She
Yeah,
goes
so we work on it and my daughter eats, she'll eat salads, she'll try it.
It used to be
She
there,
even
now
eats
they
like
do
hot
that.
salsa, like, she'll try it,
She started out like a vegetarian, and then now she's like, eats everything.
Oh, wow. So the company
She's
that we're
almost 50.
and that's a busy age.
Yeah, it's a lot better than 2.
Yes.
2 is really,
Yes. Yes.
you can't just like, doze off or not pay attention.
That's true. I like it now, my son's 13, so I can leave. I know. If I need to, it's like, okay, you're old enough. No, it takes a little bit of the pressure off. I can do grocery shopping.
You can leave them in the car too.
Yes.
You don't want to get in trouble.
I know, I'm not gonna get arrested.
All right, folks, if you want to take a seat, we'll get the second talk going here. All right, so Stuart's going to be talking about forensics in Java. All
Okay,
yours.
thanks. This is very seat of the pants. I'm going to try a demo. It may fail miserably, so bear with me. So the kind of history of this topic was, last year I gave a talk over in DC, open source digital forensics, on some disk acquisition software that I built on a project at the UW. And I said to Nimrit before that talk, basically I was trying to give Deco as a practice for my talk in DC, and Nimrit said, no, there's no gaps in CJOB talks for months, try next year. So I said, okay. So when kind of June this year came round, I looked back at the slides and I thought, oh, this is so dense, and the Java group's not going to want to see this, there's no Java on the slides. So I ditched that and did something else in June. And then when he said we had a cancellation for October, I thought, oh, I can just dig out the slides from last year, and if Nimrit's got no one else, I can stand up here and say, I built some code in Java, and everyone can say, so what, you know, because everyone had. So at the weekend, I looked at the slides from last year and then said, no, this is terrible, I'm going to revamp it, I'll do a few slides, do a demo, hopefully someone will get something out of the technologies I'm going to describe that may be useful in your work. So this is very seat of the pants. So originally the project was called Tupelo, it wasn't my name, got the principal investigator on the project that UW said we need disk acquisition software because we're doing malware analysis and we want to see bad files that are dropped by malware, and he came up with the name Tupelo. So that was the original title for the talk. Tonight is really some Java tools that I've built and can describe and share on the broader topic of host forensics. So host-based forensics is a wing of cyber security defender's job to understand all the bits that are on the disk and say that bit's bad and where did it come from. Okay? As opposed to network-based forensics, which is watching packets go by saying that's bad, where did it come from. So we're talking about disk drives. So, why am I standing here talking about this? Why do I want to do this? What are the kind of Java libraries that I built to get something that's kind of usable. I'll kind of go through Tupelo as a code base in action quickly with a demo, and at the end, when the demo kind of falls apart, I'll say aspects of search that are kind of relevant. The background is, and my idea was, you image your disk drives as often as you can, you store them in a safe place, you maybe diff them over time to say, where did that data come from? But the basic premise was, when someone comes along like Mandiant or some huge cybersecurity company and says, this Windows Registry key is bad, you can go, you don't have to go to your original user of your original drive, you can go to your stored data set and do a very fast search and say, oh, you know, the person in office number 7's got that key in the registry. Okay? So you're almost taking entire copies of entire disk drives, running operations on them so that when the indicator of compromise is the official name for when someone says, here's a file that's bad, here's a Windows Registry key that's bad, that's an indicator that your machine has been compromised. Okay. Please ask questions and want to make this pretty formal if possible. So, before I forget, I'm going to try to come away from the slides from last year. I want to talk more about some Java stuff. If anyone's interested in the original talk, it's on the GitHub website. This is the kind of GitHub presence of the department I work in at UW. And everything I'm going to describe tonight is on GitHub under the same institution. Okay. So what is Tupelo as a product, if you like? It's really just mostly Java and some C code to efficiently snapshot the entire bit-for-bit copy of what's on my system. This is a 300 gigabyte laptop, Dell laptop. Okay. When I say efficiently do that, if I took a bit-for-bit copy of this on every Friday, then in a month I've now used 1.2 terabytes. I've done this 4 times of 300 gigabytes. If I'm in charge of a department with 15 people who've all got this, that storage requirement quickly balloons. So the efficient part of this is, just because this is 300 gigabytes of data, doesn't mean I can't use tricks like compression on it as I image it. I can store the original, I can store the acquired copy, and the first capture may cost me 100 gigabytes. But in a week, this disk won't have changed very much. So the second snapshot of this disk won't take anywhere near 100 gigabytes. It may only take a few gigabytes. It may take megabytes if I did it every day. Okay. So obviously, if you introduce a large package of new software onto a system, you're going to have a big diff, and that's going to cost you in your second capture. But mostly, you can get huge compression on imaging a drive over time if you use some tricks. Okay. The big win with this system is, if I can grab the contents of this drive at 300 gig and store it in 100, I don't want to have to unpack that 100 and make it 300 just so I can do some search over it. So the nice thing about one of the technologies that I introduced called Fuse, File System in User Space, is it's a great technology to enable you to view data that needs to be manipulated and transformed as you read it off the disk. So I can do in-place searches over my 100 gigabytes and maybe my 100 gigabytes plus 4 gigabytes the next week, as though it was 200-300 gigabyte copies. Okay. So STIX, I'll show a little bit about STIX. A few years, I must say this is getting a bit dated. About 3 years ago, when I was working on this project actively, structured threat information expressions was the new hit thing in the cybersecurity domain. It was an XML schema-based vocabulary that you could share between cyber defenders to say, here's a big XML document, it indicates that such and such a file is bad. So it's a way of getting information from person A to person B, the structured way that machines could read in, and XML schema was the chosen format to describe that language. They've since kind of walked away from Excel schema towards JSON because everyone thinks it's a lot easier. I think it was a bad idea because I don't think JSON has the rigorous structure and namespace in the XML schema has. But no one was listening to me, so they now gone to JSON. So the STIX as an XML-based language has kind of fallen by the wayside a bit, but it was kind of current when I was writing this. Okay. So, right, so, why do I want to do this? Well, my idea was, and I can't believe that the antivirus people will have you believe this. You've got antivirus software on your machine, but it's using the underlying operating system to tell it what are the bits on the disk. So how can you ask the system that could be infected about the system? Because if it's infected, it's going to lie to you. Okay. So my idea for imaging a whole drive was, you come along with a bootable CD, a bootable Linux CD. We use one called Kane. It's a forensics tool, Linux-based bootable CD, and you can pile your software on top. So I've now got trusted Linux media with the tools that I need to do a disk image. I've got my $100 4 terabyte external drive. I'm going to power this laptop down, reboot off my trusted media, put in my external drive, and say I want a bit-for-bit logical copy of my 300 gigabytes onto this system. And then I go back to using this laptop regularly. I go off and walk over here, and with my Tupelo administrator's hat on, I do a bunch of searches on the carbon copy of the data here. So then I've stored all my search results, and then when the indicator of compromise comes along, I can find it here first, and then march over to this person and say, your machine's infected. Okay? So that's called dead file system acquisition, really. You're not reading, you're not asking the operating system of this machine for any of the data from this machine. You're asking the operating system on this CD. Okay? This is actually Taylor Swift, but it could be a Google CD. Eric?
So this is still work if your hard disk is encrypted?
The acquisition works fine, but the search won't, and I've never really addressed that. But you're right, it's a big problem. The acquisition is fine because the acquisition is just logical bit for bit. At the sector level, I should stress that, I'm doing disk imaging at the sector level, not at the file system level. So a disk is just a big sequence of 512 byte sectors, and you can grab them without understanding them what they are. And you can compress what you grabbed without understanding what it is. It's only when you've got the copy over here, you're now saying, right, show me all the files, show me all the file content, show me the contents of the Windows Registry, that I'm going to have a problem, and you're right. So, okay. But as someone said to me when I asked for a fix, the person said, it's all open source, you fork, and then you do the work, and then ask for a pull, and then send me a pull request, whatever they call it. So you delegate the work that you want done to the You delegate, as the producer of the software, you delegate the fixes that people want to the people. I guess GitHub's a great enabler of that. So yes, you have to power down, because you can't have this, if I'm going to reboot, I've got to power this system down. Okay, so that's one disadvantage of this approach, but I don't see any alternative. Okay, only on this have I got trusted software. I haven't got trusted software on the machine I'm trying to do. Okay. So how do I do it? Well, I've kind of been through this already. I call this a Tupelo store, just a big hunking disk that I trust and will only do my search operations on. So I've got an unmanaged disk, if you like, the user's regular disk, and I'm going to transfer that logically to there, and now I'm calling it a managed drive. Okay, and this will always be read-only on here. I'm going to grab the data, I'm going to get precise identification of this disk drive as opposed to your disk drive, and I'm going to snapshot the time at when I did it. So what builds up on this store is a kind of matrix of what and when. And I can store my drive many times, Terry's drive many times, and there'll be no clash, and each one is stored with unambiguous identification. And they're all read-only on here, because I'm never going to write to this, because it would destroy the whole idea of it. And the searches that I do over the contents of this, I can just store on this drive as well. So I call those kind of attributes or whatever. Okay. So it's kind of like a database, but the unit of storage, the cell of storage, is an entire disk drive. Okay. Any questions? Okay. So this was kind of at the end of the open source forensics slides, and I wanted to promote this right up to the front today, because this is some stuff. Tupelo is my Java C code base, and these are the things I'm using. And I'm a huge fan of Maven and the modularity that you get from Maven build small things that do one thing well, and you can pull them all in. If you just want device files, you don't need to bring a whole load of other spaghetti code in. So, because I've got quite a lot of kind of C code going on, down at the bottom there's a way of doing J and I code bases for anyone who still does that like I do. Okay. So all of these are on GitHub, and then Tupelo is kind of the application at the top of all that, if you like. So VM files, I'll come to these. How to read virtual machine content from the host. Windows Registry parser in Java. How to take a Windows Hive with no Windows API usage at all and say, oh, what are all the keys, what are all the key records, value records. STIX in Java is given an XML document that's a STIX file. How do I read it in so I can manipulate it? Okay, so if anyone has ever done JAXB, remember JAXB, XML schema parser? STIX Java is an example of a JAXB derived application. Sleuthkit is, Brian Carrier is a big in the open source host forensics. He wrote a C library for searching drives called Sleuthkit, and I just did a Java binding to that so I could use Sleuthkit, which is C program, command line C tools and library. I can integrate that into Java because then I could use it for my bigger application. Okay, and Fuse is a way of it enables me. Fuse is another C library. This is a whole Java world, so I did another binding of Fuse to C called Fuse for J. So Fuse was the enabler of a disk drive, a drive that represents something but isn't physically stored as that, and as you read it off the drive, it suddenly looks like it was the original. Okay. So the native loader, the thing down at the bottom there, it's just a framework that I've developed. I've written 3 different Java C code bases, big J and I dependencies. I've written the make file for the C bit, we've gone into the Maven part, and I thought, I've replicated this 3 times. I need a framework for this, so I built this thing called Java native loader. So if anyone ever needs to do Java C integration, and they're struggling with it, and they don't, how do you get your C dynamic library into your Java file? I've kind of solved that in this Maven artifact. So why do I need it from a forensics point of view? Well, you can't read a serial number of a disk drive in Java, but you can in C. So if I want to do it in Java, I just need to bind into C. So you write the C code to read a serial number of a disk drive, and then you just have a JNO binding, and suddenly you can read it in Java. So that's one technology. Second one was device files, and this actually addresses the fact that you can't read the serial number of a disk drive in Java. So does that say the thing I wanted it to say? Does that say the same thing? That says some of those shouldn't be on this slide. Device files is a simple one-class Maven artifact to say if I have a file like dev SDA in Linux, how big is it and what's its serial number, rather than it's just called dev SDA. Okay. So here's an example. If in Java you've got a Java IO file and you say a Linux file, a Linux whole drive file. If you look in dev in Linux, SDA represents the file that is the entire disk. On Windows, physical drive 0 is the entire thing of what you think of as the C drive with a name. On a Mac, I think it's dev disk 0. If you ask for the length and the name of those in the Java world, you're going to get nothing for that and very little for that. Okay. But if I use my device file class, you just give it a regular file and its constructor, and now I say, how big are you? I'm 300 gigabytes. What's your name? Well, I'm a Western Digital ATA blah 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 serial number. This is the string I need to say when I image my drive and I image Terry's drive, they're different. I can store them with that label in my store. Okay, without that unique identification, this whole thing will never work. Eric?
Yeah, and some of those features that the Java names include path and UIO.
I've used path and an UIO, but I've never stumbled on that. That would be useful. That would have saved me the trouble of doing this. Maybe I could claim that this was prior to Java 8. I can't quite remember. So this is a big win. I need this serial number off the drive, otherwise I can't do any of this. The size is kind of it doesn't really matter. I'm just going to read this drive. I'm going to read off this disk until I see end of file. So the size doesn't really matter. Okay, Sleuthkit is an open source C-based forensics library that basically knows how to walk many different file systems without using the underlying file system given by the operating system. So imagine Sleuthkit is a C library that knows NTFS, that knows ext3, ext4, it knows RiserFS, it knows whatever the Mac file system is. Okay, it knows it by itself, so it doesn't rely. All it's asking the operating system for is set to number 473, and then reads that as metadata of maybe an inode table or whatever, or a Windows, what do they call that? NTFS unit of storage, I can't remember, file table entry. Okay. So Sleuthkits, and I use it in my system, a fabulous way of walking a file system saying, where's the files? Are they deleted? Are they, how big are they? What's the permissions, ownership, stuff like that. Okay. Oh, I need that in Java, so I needed a binding, so I wrote TSK for Java. Okay. That now enables me to call Sleuthkit from my Java applications. Okay. So an example, and I'll run a couple of these on my system. So bear with me, I'm just going to do a bit of typing. So this says, find me the partition table of this drive. This says, walk the file system that's at this offset in this drive. This says, what's the name of the inode? What's the data associated with the inode 13? Okay, if you want to walk an entire file system, so these are all basic C Sleuthkit commands. Okay, so I'll just run one of these. So if I do a mmls on dev SDA, Sleuthkit is telling me, it looks like a two Linux partitions, probably a swap partition and a real partition. So none of this is Java, this is just C mmls Sleuthkit operations. If I do FLS, so you see here, this is the offset of the first partition in the drive, so I might say minus R for recursive, minus M for pathing, minus O204A, and dev SDA. Oh, that's not right. So it walks, Sleuthkit is walking my entire Linux ext3 file system, showed me various aspects of all the files. Okay, so you can see some paths, some ownerships. You see modify times, access times, create times. Okay. So that is what I want to do when I grab my data. I want to search my data for all the files that are on the data. Okay. So that's a very quick intro to Sleuthkit and my binding to it. Virtual machines, when I was doing this kind of cybersecurity tools at UW, but in anger, I don't do it anymore. We did a lot with virtual machines. You infect a virtual machine with malware, you let it run, you see what it's doing on the network, you see what it's doing on the disk, power it down, you kind of wipe it off, you start with a new virtual machine. So virtual machines are big because they're convenient, much faster to revert and start with the system that you know than it is reinstalling the whole operating system on a real disk. Okay. So, but if you use kind of the kind of, not really almost the hobbyist or the home user or small office versions like VirtualBox or Workstation. Anyone here use VirtualBox? Anyone do anything with VMs? Yeah, one or two. Yeah. Okay. So if you look on the drive, if you look on your disk drive, if you've got a VirtualBox VM, that's not in a file format that looks like a whole disk. Because VirtualBox are doing tricks with compression and only allocating parts of the disk when the user's files are going to land there. So it's a file format that basically is not searchable by something like Sleuthkit. Okay. So I thought, wow, I love the challenge of file format parsers. So I wrote a parser for a VirtualBox VDI file and same for a VMware VMDK file. So now suddenly I can read the contents of these files that are on my disk as though they represent the contents of the virtual machine's hard drive, but they only represent it. They're not bit for bit they represent it, but then they don't store it, if you like. So they store it to the VM, but they don't store it to you. They don't look like that's the contents when the VM's powered off. So I thought, no, I can overcome that. So now integrated into my Tupelo system is I can do it on virtual machines. Although I've been talking about you come in with your CD, you grab your laptop, you put it on your store, and then you search it. I can actually do demos of all that by saying if I've got a virtual machine on my laptop and it's powered off, then it satisfies the constraint that it's dead file system analysis. Because if the VM's powered off, it can't lie to me about its contents, because I'm not asking for the operating system software on the VM. I'm just looking at the file the VirtualBox manages for that VM. So that's why I'm implementing this virtual machine volume. This isn't the only technology that can mount a VM drive from the host. It's just the only one I've seen in Java, if you like. So Fuse, question?
Yeah, how would VM balls compare to something like Vagrant? And what virtualizations virtual engines does it support?
Basically VMDK files, which is produced by VMware, but sometimes used on VirtualBox, and VirtualBox's native VDI files. Just those two.
Okay.
Okay, so not Microsoft's, whatever it's called, hypervisor, I can't remember. VXD files, it doesn't matter themselves. I basically wrote this for the VMs that I was using at the time. Okay. So Fuse is a C library for presenting data that's not really files on a file system as though it were. Okay, that's very handy for me, but Fuse is in C and I want a Java binding for that, so now I can use Fuse in my larger Java applications. Okay, any questions? Okay. So there's a very, very quick run through of some of these technologies. So if I've got on my system, if I've got the contents of all my VMs are under a certain VirtualBox directory. So here's one Windows 7 64-bit VM. It's got some XML file that VirtualBox manages, and this is what represents the hard drive of that VM as a disk on my host. But I can't just read this as is and say, find me all the files on that drive, because it's totally VirtualBox managed file. Okay. But if I make myself a directory, and this is basically a driver around my VM involves Java code. Now, if I mount this, now I can look at the mount point, and it's the contents of the entire file. At the entire disk. Does that make sense? I'll just demo that quickly. So if I say, what have I got here? Have I got mount point? I've got 10. So if I say VM mount Windows 7 base on temp, now that's going to stay in the foreground. If I say ls temp, now temp looks like it's the entire contents of a drive. So now I can run any Sleuthkit command on there, and it shows me the partition table. So I've now got access to the contents of that VM as though it was a physical disk, which is very handy. So I'll undo that. Okay, so that's what I'm getting at with this slide example. I can get at VM contents from the host, and therefore it's a good way for me to test my Tupelo ideas out, rather than, it's laborious to power down this system and do it all with a CD, so it takes a lot longer. Okay, so I've waffled on about what STIX is. This is MITRE's own description, and like I say, this is started off as XML schema description, and it was complicated, but at least you knew when you were getting a document, you know, if someone had said, I don't know, Windows Registry, key, whatever, you knew that noun was in the namespace of someone defining that. The problem, I think, they've kind of walked away from XML towards JSON representation, and I think now people are starting to say on these lists that I'm on, oh, this isn't working, maybe we should have stuck with XML schema. So, but STIX itself has survived, it's just kind of morphed from an XML-based document representation to a JSON one. MITRE is a kind of federal company tasked with bringing standards into various avenues of IT. Okay. So that's a very quick introduction to STIX. So I wanted, at the time when we were doing this, we were always promised that we were going to get these indicators of compromise from the federal government about bad stuff on people's systems, and it was going to come out as in XML. And I thought, well, I need to ingest that. I need to be able to see a STIX document and just walk it and say, oh, there's Windows registries, there's bad IP addresses, there's bad files. Now I'm going to take that information, go to my storage of all my drives, and hopefully not locate them, but if I locate them, then I go back to the original person and say, you know, I need to get your system. You've got some bad stuff on your machine. So that's another one of my kind of products, is a Java STIX binding. Okay, so an example STIX document, if I just go and Mandiant wrote a big, so if I just, this was at the time the sort of size of XML, so a lot of free-form English text, but you've got some XML elements, you know, it's very, very dense, but it's very precise for all the namespaces used. I mean, it's pretty horrific. And somewhere after all the descriptions and annotations, maybe something that you could recognize. You know, someone saying blah, 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 behavior of malware is doing such and such. So, you know, you can't do that with grep. You need something structured. So, X, you need code that can read that a file like that. Okay. Where am I? Oh yeah, okay. So, and what I've just been working on just over the weekend, because I'd said last year, oh, and I've also done a Windows Registry parser. I'd never really finished that, and I kind of have now. So, if you wanted to read offline Windows registries in Java, then you could use my Java library to do it. So it basically understands the data structures of a Windows registry hive. And so my idea was, and I never really finished this, was one of the search things you would do when you've got the carbon copy save file, disk contents, you just walk over all the files on that file system that look like they were Windows registry hives, and you store all the data. So when the indicator of compromise said bad key, you'd say straight away, very easy search. Don't have to go back to the original user's machine. Okay.
Stuart,
Yes. Yes.
what do you really mean by hives?
Hives, a file on disk that represents part of the Windows registry. Kind of Windows System 32 config, like SAM, software, default user.
What does hives mean to you?
Just the description of the files in a Windows system that contribute to the registry seem to be called registry hives. I must say I'm not a big Windows user. I come at this from the Unix side, just trying to understand Windows data structures.
When you see H key underscore user, H key means hive key.
Oh, okay.
Okay. Okay. All right. So if you take all those enabling technologies and throw them all together in a big application that can do this disk acquisition, efficient storage, and search in place over the stored data, and then holds the results waiting for indicator of compromise to come along, or even, you don't even need the indicator of compromise. If I image my drive tomorrow and store it on here and do a search over all the files on it, and then I do it again next week, I can look at the diffs on this system about this machine, and I might say, I didn't install anything in that directory. Where'd that file come from? Okay. So there's two aspects to this. One, you can diff your own results, and two, you can wait for someone to come along and say, you've got bad stuff even though you didn't know it until now. Okay. Does anyone want to see a demo, or are you all out now? Because I don't mind either way. Okay. Okay, so bear with me, because this may bomb. So I'm going to have to go to my trusty editor and look at my demo instructions, because I didn't bring a piece of paper with me to write this down. So, make a VM. Okay, vbox, manage, clone. First of all, let me list what I've got in terms of VMs. Okay, vbox, manage, clone VM XP base. So Windows XP base virtual machine. Call it cjug and register it. Okay. You could go through the VirtualBox GUI, but I'm a command line kind of guy, so. Oh, maybe you can't see all that, it's too far down. So I'm cloning a VM because I want to play with the cloned copy and I don't want to ruin the original. So this is taking up disk space on my Debian laptop. And it's a Windows, as you can probably infer, it's a Windows OXP image. Come on, live demo, you don't want this. Oh. It's 10, I should say, it's a 10 gigabyte logical system, very old system, and 10 gig was probably enough. But that's good, because otherwise you'd take hours. Yes, question?
So that diagram that you presented earlier, was it kind of is it layered like a cave, or is it layered like flat, one-dimensional?
The dependency graph
Yes.
there,
Yes.
that's just the natural dependencies between the Maven artifacts. So this depends on just Java system libraries. This has got C code in it, so I use this framework to bundle the C and Java code together. This has got C code in it, because I'm binding to Sleuthkit and C, so I use that. This has got binding to Fuse, which is C code, so I use this. VM files uses Fuse for J to enable me to see these as disks from the host. This is pure Java, this is pure Java, but Tupelo uses all of them.
So are each of those programs as well?
No, each of those, this is the only one with like a main in it. These are all like Java libraries composed as Maven artifacts. Well, my build tool is Maven, so if you check this out from GitHub and type Maven, it'll build you a jar. And then you need that to be able to build that. So you check that out of GitHub and you do Maven on that, and now you've got 2 Maven artifacts in your local repo. So if you just walk kind of in the reverse up that diagram, finally Tupelo would build. What I'd like to do, and never have found the time, is to put the binary versions of all these on Maven Central. But to do that, you've got to contribute the source code, and I'm not averse to that because it's all on GitHub anyway. But you've got to do a CPG key and all that. So, has anyone ever contributed to Maven Central? Is it laborious? Is it painful?
Yeah, fortunately, I had a really long script to follow other people.
Okay. So because I don't have these artifacts in binary form on Maven Central, to build something at the top, you've got to get all the sources from GitHub and do the build yourself. And you could argue that's in some ways better because now you get to stare at all the source code rather than some of it. Question?
So you're using STIX to consume these XML files that identify suspect files?
Yes.
And what repositories are you using as a source for those XML files? Is there like
that never really came to fruition. It was all, when STIX was kind of in the XML schema form about 3 years ago, it was all like, this is really going to take off, everyone in cyber defenders world is going to be sharing this data. I've really never seen it happen.
So then what sort of files are you consuming with that?
I'm not consuming anything. This is almost kind of latent ideas. I don't work on this anymore.
Okay.
I'm presenting this because Nimrod said he didn't have anyone. George, that's not true. The Windows Registry stuff I was working on the weekend. George.
So your native C code that presumably talks to the hard drive, it talks to it through what kind of layers so that it can run? This will only run on Linux, or will it run on the Mac or Windows box?
Actually, the acquisition stage is pure Java. It just says, open me dev SDA and read till end of file. So the acquisition stage itself is cross-platform.
And the actual...
But the thing is, to ensure dead system analysis, you've got to be on a boot CD. So if you can build a Windows boot CD, fair enough. It's easier for me, because it's all free, to get a Linux bootable CD, pile my stuff in it, and then you are imaging from Java from this boot CD, but the acquisition phase to say read every bit off this disk. I mean, you could do Tupelo acquisition of this machine from this machine. It's just that I would argue it could be lying to you. Okay? But the acquisition stage is pure Java and therefore cross-platform. Was there another question? Yeah.
Yeah, I was just curious, has the new form of this file, threat file publication come to fruition?
There's a few people talking about it. I haven't really seen anything. I've never seen anything as in-depth as that Mannion report on what was called the Chinese Advanced Persistent Threat, the APT1 report that's called. I've never seen anything like that. But actually, I've never seen anything that dense since, and I think that was 2013. So I'm on the STIX mailing list where you don't see a lot of real data. Everyone's hoping it will work, but no one seems to want to jump first. Okay. Any more questions on the dependency graph? Okay. Did that answer your question? Yeah. So where was I? Oh yeah, demo. Okay. So I've got a VM that's cloned. I'm now going to go to my, imagine that, so the VM is off, so it satisfies dead file system, it can't lie to me. Okay. So I'm going to do, so who uses Git from the command line? Anyone? Okay. So like Git, one command, many subcommands for Tupelo. So tup is just a shell driver around the Java code. I can say add, just so I can use short names to identify the disks and the store, if you like. I'm going to say device add vbox cjug and call it, I don't know, SJ. No, that didn't work. Why didn't that work? No, that's not right. Sorry, don't do live demos. Add SJ, the local name for the VM. No? Okay, so someone give me an identifier, a short identifier that represents a short name for a whole drive. Anything.
SJ2.
SJ2. Okay. SJ2. Okay, so because it wasn't a physical drive with a real serial number of a Western Digital disk, I've invented an ID. There's some metadata in the header of the VDI, of the MDK file. So I basically said, this is my unambiguous identifier for this disk drive of that VM. This is the size, 10 gigabytes. I can now call that SJ2. So I can now say things like push, just like git push. Push is the transfer of all the data from this system to this system. Whereas in this demo, it's the VM's disk to my real disk. Okay, so I can say push SJ2, and I've got a test store called TS. So it's saying the what, the unambiguous identification of that disk is that label. The when is just I've got a kind of incrementing counter with today's date and the number of times I've done it today, just as a friendly, easy to read timestamp. Okay. So I basically grabbed 10 gigabytes off that VM's drive, and it only cost me 1 gigabyte to store it. So there's a big win. Okay. If this was terabytes, it's handy that terabytes suddenly go down to hundreds of gigabytes. Okay. So I've got 10 times compression already. Okay. So I can now do some operations on that store. I can say what's in my store, TS, store, sorry, live demos. So I've been doing this in practice, so I've got the new one, I think is, where would it be? 06. 06 down here, number 6, is that right?
I didn't know it was 06 and then we go off the top.
No, it might be off the top. Yeah, it might be number 1. Okay, so probably pipe that through less. Okay, so this is what I just grabbed. So I've grabbed the entire contents of that hard drive, logical 10 gigabyte hard drive, and it's number 1 in my store. Okay. So I can now do operations as though it was on here, but really it's just on my drive. I can say I can digest it. Digest TS. TS number 1. What I'm doing to digest is, and this is where we're doing, I'm running a tool now on a 1 gigabyte file that represents a 10 gigabyte hard drive without unpacking the 10 gigabytes. That's a real win. Okay? So I'm walking the logical 10 gigabyte drive and I'm just digesting it every either megabyte or 64K. I'm saying, what is the hash of this number of sectors? And I'm storing that. And then I'm walking along the disk. What is the hash of this number of sectors? And I'm storing that digest alongside the data. Okay? The reason I'm doing that is, when I next push this disk, I want to compare the new data with the old data, because I don't want to push the logical 10 gigabytes again. Well, I do want to push the logical 10 gigabytes. And everyone see, it's an optimization that huge chunks of that drive won't change over time. Okay? So the smaller you want your hash sector sequence to be, obviously the more hashes you'll pay for. But the bigger you make them, if you've got one file that changes in a set of sectors, you'll have to re-push all of those. Okay? So that's why I do a digesting operation. So if I just do, what does my store look like? We look down here, my MD5 is the thing I just hashed. This is a Tupelo managed disk. So these are the files on the real disk that represent the disk capture and operations on that disk. Okay. So now I can run another Tupelo operation. I can say, I want to produce what's called a Sleuthkit body file. And now it's mounting it using Fuse. It's mounting that 1 gigabyte file as though it was 10, identifying all the file systems on it. It was Windows XP, so it would have had one partition. And it was probably started at some sector 63 or whatever. So it's found a file system and the only partition on that drive, and it's just walking through that file system, making a record of all the files and the properties of all those files. Okay. So if I look at that on my host, can anyone remember what that was called? Tup config. So SJ2 is this one. That's one. Okay. So if I just want to show you. You'll see here in the path, I'm storing the what and then the when unambiguously. So I've always got a place for all the products of each search. And the body file just looks like that thing from before. Okay. So here, this is the MD5 hash of that file in some inode number, some permissions, owner, group, size, Windows creation time, maybe Windows last access time, Windows last modified time, Windows metadata last modified time, or whatever. I'm not particularly an NTF expert, but that kind of thing. So that's Sleuthkit via my Java bindings has walked that entire partition and stored that data in my Tupelo store. So now when the indicator of compromise comes along and says that file is really bad, you know straight away it's a very easy search, and you know exactly when it was there. If you've imaged it many times, you can see when it wasn't there and when it was there, and you know exactly whose original disk drive it was. So back to my. So I'm now going to boot the disk up. We haven't powered it on yet. So start VM CJUG. Is it called CJUG? So now imagine that you're the regular user of this system. Don't worry about that. So I can remember Windows XP days. So okay, this is a completely canned example, but I've got I've got a VirtualBox share back to my host, so I can feed this VM data from my Linux system. And I'll do that right now. I'll go to my command prompt, I'll change to my shared drive, and I'll run something called don't click on me, which you don't want to do in your web browser. So I clicked on something, I'm not sure what happened. You know, that happens all the time. Oh, you know, what do? You take your system to your IT person and they look over your drive, whatever. So you've infected the VM, basically. That was a malware botnet from like 10 years ago, renamed by me for a bit of a cheap laugh. So I now power off. But this disk has changed. I've done something to deliberately change the contents of this disk. So if I power off, now I'm back to having satisfied. I'm going to do a Tupelo disk capture of that VM, and it can't lie to me because it's powered off. Okay. So I'm going to go back to, and I'm going to push it again. Push SJ2 to my test store TS. And now look, it says, oh, I've retrieved a prior digest for that disk at this time. So I've asked for the store, show me all the hashes from whenever I imaged it last. And now now the differences are even smaller. So it's logically 20 gigabytes because I've captured 10 gigabytes at time 1, and march forward in time, infected the system 10 gigabytes at time 2, but the physical captures cost me 1 gigabyte before. Okay, it was only powered on for 2 minutes, so it's not going to change this much. But you see the idea, the digesting gives me a huge win in the amount of data that goes to the store the second time. I should just point out, I've been doing this to a local store, but this also works over HTTP. So you could have your store on your network. You march into someone's office with your bootable CD, you power their system down, you put it in, you define your store to be some HTTP site in your department, and you do the push over HTTP, and you've got a store waiting at the other end. Okay. So that was the push. I need to do the body file operation. If we ask for information about this test store, is it number 7? I can't remember. One of the problems here is I can't identify what they were. I'm trying to find the same drive, because I had some previously, which now seems a bad idea. So number 1 was number 6, so it's number 2, I think. It's the same drive at a later time. Okay, if you look at the labels. So I want to run the Sleuthkit search operation over image number 2 in the store, which is just that. And now what I've got, logically, if it were on a real system, I've got this disk drive imaged twice, and the file system contents stored alongside the logical content on my safe place. Okay. So it's done. Okay. So I can say. So now I have a body file, which is a Sleuthkit general summary of a file system. I have one for number 1, and I have one for number 2. So now my demo kind of ends from a Tupelo point of view. What I really want to show you is what happened to the drive between those 2 times. Okay. I don't have this in a Tupelo search command because I never really implemented the search. What I can show you is I did write a program that shows off the Java bindings to Sleuthkit called Armor. And the joke was, if it's called a body file, and I write a shell, a body shell is some armor. So that's a joke. So if I can do test store, so what I'm doing now is just showing you the contents of 2 body files, which represents the state of the disk file systems at 2 different times from the same drive. So, sorry, I need the label for the SJ2, 13B6. So if I do armor, test store, disks, VMDK 13 at time 6, attribute into the body file. And the same thing, MDK 1.3, the second snapshot. So this is just a little program that can manipulate these files that are called body files. What? So it's read these two files in, and I can now say, what things can I do in this little shell? I can list the things that I've got with ls. I can say, well, show me the first one in a tabular form. So it's just a Java swing thing. So this shows somewhat of the Sleuthkit can't do this by itself. If you've got Java in front of it, then you can do any display stuff you want. So if you look at the label of this Java swing frame, it says the what and the when are kind of labeled, buried in that file. Basically, this says, this is the acquisition before I infected that XB drive. Okay? And I can say, well, show me it at later 2. And this is every file on the disk after I'd infected the file. So now, with a bit of algebra and a bit of set manipulation, you can say, show me all things, you can just do set differencing. So newer files are basically elements that are in this set that aren't in this set. And deleted files are just the reverse, the elements that are in this aren't in this. Okay? So if I have a few operations defined, so my ops, so number 1, my operation number 1 is all the new files. So if I say op number 1 using body file 2 the later time and body file 1 the earlier time, gives me a new body file, because just kind of, what's the word, closure? Yeah, I run a set operation, a set difference in operation on 2 artifacts that give me another artifact of the same type. So my number 3 has just got created, so I can say, well, give me the table for 3. And now there's a very, very small number of files. But it has identified, because I know the infection, second one from the bottom, Windows System 32 mstc.exe, you know, on casual look, that just looks just like the Microsoft binary, because there's one called mstsc, which is, I think, the terminal emulator program. So the malware has buried itself persistently so it starts up the next time the machine's booted in Windows System 32. And you probably couldn't do that these days. Back in the day when this was live, you could do that. But you also know, in the time between me powering it on the first time and the time me powering it on the second time and infecting it and then power it off, they're all the files that changed. Okay, so I know, because I know this botnet, that the one right above this is the malware artifact. When I said don't click on me, it buried itself in the Windows System folder. And I know that right above it is the keystroke log file. That malware had keystroke log. Every time you type something, it was recording that, and that was the file it was recording it in. So not only do you see that file should have been new, I didn't install anything in there, but you also get context. You get what came with the infection. Okay? Question?
Can you give us, what do you mean by malware? Is it like...
Anything running on your computer that you don't know about and you would remove it if you did know about it, as a loose definition.
So most software has pre-installed
Yeah. So malicious software, stuff that you don't want, stuff that's stealing your credit cards or recording your keystrokes, and at some point in time, that binary, that program, is going to upload that keystroke log file to some mothership. And someone's going to be there looking at everything you typed on your system.
So would you say some cookies or even hashing is not malware or malware related, or?
I mean, it's so broad.
Yeah.
I would just describe it as any software running on your machine that you don't know about and you would get rid of if you knew. That's my kind of almost joke definition. But, that was a peer-to-peer botnet, didn't use any DNS, would store neighbours in the registry, do all sorts of crazy stuff, keystroke logger. So that's the demo of image a drive, store it safely, do something with it, image a drive again, search operations on the drive. So if I go back to, I think I've got 2 slides left on my JavaScript didn't really run in as a Tupelo command, but I will get there eventually. So demo, I just tried to do that. And so following on, the last stage with this would be, so I've done a diff of my own system without any external information from anyone else, and I've already found something, well that looks odd, why is that in the Windows system folder? I didn't do anything. Well, you clicked on something and said don't click on me, that's a problem. Okay, so someone will come along with a STIX file and they'll give you this huge STIX file, and inside it you might say, if you see a file on your system with that hash, it's bad. It may be renamed. In fact, just a single hash of a file is pretty unreliable now. It's bad stuff that can work very easily. Just have know what the instructions are. But you get the gist of it. You get an indication of a compromise, and you now go back through the stuff that you pre-searched, and you say, well, I'm going to look that up. Yes, I do have that, or I don't have that on that system, and that system, at time 1, time 2, time 3. So what I would like to do is to show you that as just a search subcommand, but I haven't really got it. But it does show you the what and the when. Now you know back in time that it wasn't on there then, and then it is after that. Dan,
So the hash of the file is based on what?
whichever hash you want, MD5, SHA-1,
No, but what's it looking at regarding the file itself?
content.
So could a file modify its content to sort of spoof itself from the hash, so it's never static?
Yeah. Hashing files to identify bad stuff isn't really reliable. It's a bit amateur, but 10 years ago it was all there was. That's when the bad guys realised that was happening and just did what's called polymorphic, where they just add a few bytes at the end or whatever. So,
what's the state of the art?
I don't work on this anymore, Eric, so I don't know. But every time, I remember last October when I stood up in Virginia and gave this talk, and it was less Java-y. In the news that day had been, I remember the Dirty Cow, the Linux vulnerability in the kernel. And the frequently asked questions was, how do I get rid of Dirty Cow if I've got it on my system? Well, and the FAQ response said, I think I quoted it at the time, it said something like, well, if you had the contents of the disk before and after, you'd be fine, you could revert. And I thought, that says everything about my talk. I want because I haven't really talked about it, but if you've got the state of your disk at time 1, an entire bit-for-bit logical copy of the drive, and you've got it at time 2, you can just wind back, almost like virtual machine snapshots. So this has actually got some utility. If you take your laptop to some conference and you think you're going to be infected over the Wi-Fi, if you were to image your drive and store it somewhere safe, and then image it again when you get back, you could say, oh, that's bad, that's bad. Why don't I just wind back in time and take the copy that's on here, and instead of reading it from my laptop, write it to my laptop. Then you've almost got a kind of whole disk backup strategy as well, for free in some respects. That's all I have. Thank you.
All right. Any final questions? All right, I guess not. Well, thanks for coming, folks. I'm sorry, go ahead. Sorry, Doug.
So, if I understand correctly, the compression strategy is sector-based? But
The compression strategy.
You do hashing in sectors, so you're hashing in sectors.
Good question. Okay. Is this writable? It is now.
It's writable, it's embracing it.
Okay. Good point.